For 5.2 notes today on solving quadratics using square roots, we're going to basically build off of two of our previous concepts. One is just simply solving by reversing PEMDAS, doing the inverse order of operations. Quick, gentle reminder. When you simplify something, you PEMDAS. Going from left to right. So that would be the word simplify. Or evaluate. Those are both interchangeable. When you solve something, you are finding what a missing variable is, and you actually reverse that process. You SAD map it. You do inverse operations. You work it backwards. So to simplify is to PEMDAS, to solve is to SAD map. Now we're also going to be looking at simplifying radicals when we do this, which we already have refreshed. So it should be quick and easy stuff you've already done. We're just combining two of our previous topics. So let's talk this through. On our first example, we have 1/2 x squared equals 20. We're going to solve, and we are going to reverse PEMDAS to do that. Now, we don't have any subtraction addition, so we get to go right past that. We do have division multiplication. You have multiplying the variable x by 1/2, so we're going to undo that. Now, to get rid of a fraction, the easiest way to do that is to multiply its reciprocal. If you divide by a fraction, because technically you have multiplying by 1/2, it's not actually wrong. There's nothing wrong with that. But when you see 20 on the other side of that equal sign divided by 1/2, that's a challenge for a lot of kids, including myself. So instead of dividing by a 1/2 to get rid of multiplying by a 1/2, a quicker way to do it would be to multiply by its reciprocal. A long time ago, somewhere in your middle school math schooling, you learned that to divide by a fraction is to multiply by its reciprocal. They do the exact same thing. So the reciprocal of 1/2 is 2/1, which is really just 2. So that's what we're going to do. We're going to multiply both sides by 2. The 1/2 and the 2/1 reduce completely. So you have x squared only on the left-hand side, and 20 times 2 on the right-hand side just became 40. So now that you're here, you have taken care of that step. Our next step is to get rid of any exponent. That would be the square. The opposite of a square would be a square root. So you're going to square root both sides. Now, when you do that, every time you take a square root on both sides, I call it forcing the square root, because you were the one that chose to make the square root happen to get rid of that square. You have to show plus or minus. I want to remind you why this is the case. I'm going to do that in just a second. Let's finish this one out first. So the square root of 40. X equals plus or minus the square root of 40. Remember, 40 is 4 times 10. It's also 1 times 40 and 2 times 20 and 5 times 8. But the perfect square that's biggest would be 4. So if we rewrite this as 4 times 10, underneath that radical, the square root of 4 can come out of the house. And when it comes out as 2. So our final answer, instead of writing plus or minus the square root of 40, we're going to write plus or minus 2 square roots of 10. Because the 4, the perfect square of the 4, came out of the house as 2. So why is it plus or minus? I'm going to sidetrack in the upper right-hand corner of the screen. So if I asked you x squared equals 4, what is x? Without skipping a beat, almost everybody is going to say, well, 2 squared is 4, so x must be 2. But the other half of that, since when you square something, you multiply it times itself, x could also be -2, because -2 times -2 is also positive 4. So when you solve by finding the square root of something to get x by itself, to get x isolated, you need to show plus or minus, because there's going to be actually two different values that make that statement true. In this case, positive and negative 2. Okay, let's do another example. Now, this time, it goes a smidge against SADMAP. But see, the thing is it's really following SADMAP. You just gotta pay attention to the fact that order super matters, and sometimes you have to hold off on what you think is supposed to happen because you really have a bigger picture at play. So when you have an example 2, x minus 3 squared equals 7. I definitely see subtraction addition, but it is protected in a parentheses, which is last, and that parentheses can only be unlocked by getting rid of the exponent, which is second to last. So you have to actually pause on getting rid of the subtraction addition, and clearly there's no division multiplication, so we skip that, and unlock the parentheses first, which then allows you to access the minus 3 inside by getting rid of that exponent. So we're going to get rid of the exponent by square rooting both sides. Of course, what you do to one side, you do to the other side to keep it balanced. The square root and the square are inverse operations, so they cancel each other out, which leaves you with x minus 3 no longer needed to be protected by that parentheses. And then on the right-hand side of the equal sign, because you forced the square root, you have plus or minus 7. Now, the square root of 7, excuse me. That 7 can't be reduced, so we just leave it as the plus or minus square root of 7 because no one wants to write that as a decimal, and there's not a need to. So the last thing is, now that the exponent's been done and the parentheses has been unlocked, we get to go back and finish SADMAP. We just start back over again. Anything being added or subtracted. So in this case, we're going to add 3, and protocol, that's math protocol, super fancy, tells us to put that 3 on the other side in front of the plus or minus. So your final answer is x equals 3 plus or minus the square root of 7. Now, I want you to notice that is 2 different answers. That is 3 plus the square root of 7, whatever decimal that is. It's going to be, let's see, square root of 4 is 2, square root of 9 is 3. So it's going to be, 2 point something-ish, 2.6-ish maybe, plus 3. So it's going to be like 5.6-ish. And then the other one is x is 3 minus, that 3 is terrible, I'm sorry, the square root of 7. So 3 minus 2.6-ish. So 0.4-ish. Anyway, no one wants to figure out those ishes, right? Those decimals. So we just leave it. And just to make it simple, you can certainly write it separate, but why? Why do that when this beautiful plus or minus symbol gets both of them done at the same time, quickly and most efficiently? Okay, moving right along. So again, to solve is to SADMAP. Example 3, negative 4 times x plus 1 squared minus 12 equals negative 20. We're going to do SADMAP a couple times on this one. For starters, is there any subtraction addition we can currently get to? Yes. Now, there's addition inside the parentheses, but we're going to have to hold off on that because we can't go in there when the parentheses and the square is blocking it. So that one's kind of like blockaded. But the minus 12 on the same side of the equal sign as the x can totally get moved. So we're going to add 12 to both sides. So we have, updating our problem, negative 4 times x plus 1 squared equals negative 8, which is negative 20 plus 12 on the other side of the equal sign. Okay. Do we have any division or multiplication we can get rid of? We do. We have multiplying by negative 4. So the opposite of multiplying by negative 4 is dividing by negative 4 on both sides. We update our problem. X plus 1 squared equals positive 2 because negative 8 divided by negative 4 is positive 2. Now, do we have any exponent we can get rid of? we do. We square root to get rid of the square, which in turn unlocks the parentheses because it cancels out the square. And then we end up with x plus 1 equals a positive, negative, a plus or minus square root of 2. That has in turn unlocked the parentheses, and we are now ready to start all the way back over with any subtraction, addition, or division multiplication to get your variable by itself. In this case, we have adding 1, so we're going to subtract 1, and protocol says put it in front of the plus or minus. So you end up with a beautiful x equals negative 1 plus or minus the square root of 2. That's two different answers written as 1. Your turn. Okay, I gave you a head start. Divide by 2. X squared equals 96 divided by 2 is 48. Force the square root. Plus or minus. 48 is 16 times 3. That's the biggest perfect square. 16 comes out of the house as a beautiful 4. So your final answer is x equals plus or minus 4 square roots of 3. Get a head start on number 2. Pause the video if you want, because I'm going to go ahead and move forward. We're going to subtract 1. Three times w minus 4 squared equals 15. We're going to divide by 3. W minus 4 squared equals 5. We're going to force the square root. W minus 4 equals plus or minus the square root of 5. And then to get w by itself, we're going to add 4. So we're going to put a positive 4 in front of the plus or minus. Final answer, w equals 4 plus or minus the square root of 5. Example 3, m squared over 10 plus 2 equals 8. We're going to subtract the 2. So m squared over 10 equals 6. The opposite of dividing by 10 is multiplying by 10. So m squared equals 60. Force the square root. M equals plus or minus, let's see, 60. 10 and 6. Goodness, can 64 times 15? Let me see if that right. 15 is 3 and 5, and 1 and 15, so it can't break down at all. So yeah, 4 times 15 is the same thing as 60. That's my biggest perfect square pair. So then that comes out of the house, the 4 does, excuse me, and that becomes m equals plus or minus 2 root 15. And last, add the 5. Example 4, 3n squared minus 5 equals 31. So we're going to add the 5. 3n squared equals 36. Divide by 3. N squared equals 12. Force the square root. N equals plus or minus. The square root of 12 is 4 times 3. Under the radical, 12 is 4 times 3. So then that would be 2 root 3. So n equals plus or minus. 2 comes out of the house, 3 stays home. And that's it for today.